Okay, hello. So we're going to work on our practice quiz for the exponential growth and decay. So our first one, everybody, it says the population in Midway is expected to decrease by 3,600% per year by an exponential decay function. So that means we're going to do A is times the 1 minus the rate as a decimal, everybody, raised to the time. Everybody, this is raised to the time. Approximately what year will the population be? About 3,728 people. Okay, so it's going to be, starts with the population, or A, initial condition, is going to be 4,007. 1 minus the rate, so 0.3600, we divide that by 100 to get 36 10,000s. Okay, and then the time in years. So then I graphed it and looked at the table. So I graphed it, and then I looked at the table for this. So I did the graph. We have the graph. And then I did second table. And it would be at about 20 years. Okay. I did change the window, everybody, so that the maximum was 5,000 and the scale was by 100 because it started with 4,007. So I knew that I needed to make it so I can see on the y-axis, everybody, I need to be able to see the population. Okay, for this one, it says your friend deposited $5,000, an account earning 1.2%, 1.2% interest rate, annual interest rate. Find the balance after 20 years when the interest is compounded daily. It would be 365 days in a year. So end value is going to be 365. The rate is a decimal. Drop the percent sign, move the decimal to the left, add the decimal and the zero. Principal is $5,000, so 5,000.012 divided by 365, so 1 plus. Raise it to the 365 times 20. So really that's a times button, times 20. Okay, notice it says enter the number only, round to 2 decimal places. So it would be $6,356.22. We put our answer in. Right. So we got, notice it's 22, number after is 0, so we just leave it as 22 cents. Everybody, if that number after is 5, 6, 7, 8, 9, we round it up to 22 cents. Okay, this one we're doing the growth rate for the model. It has E, so we want to know the growth rate. So remember, it's principal. E is equal to the rate times time. So that means we're going to be using this rate right here. So 28,000. So I take and multiply that by 100 to get 2 8/10%. So it would be 2 8/10%, everybody. Okay, which exponential function is shown in the graph below? Okay. So one thing, everybody, remember, it's y is equal to a b raised to the x. Okay, everybody, I know this is showing e, but a, oh, you can't see that part. A is our initial condition. Our y-intercept. So it means that y-intercept, everybody, there is 11. So that means A is 11. So it means for the graphs, I know it's not this one, not that one. Okay. So then we're going to put these in. Remember to get E, everybody. We do second division sign to get E. So I'm going to graph it. So 11, second division, raised 0.03, x, parentheses, window, and then we change it back. Oh, it looks like we need to be able to see, but we can do -10 and 20. and put it back to 1, everybody. Number 5s. Still looking like that. Okay. It's going up, so it's going to be this one. Everybody, good. Okay, identify the growth models listed below. So remember with growth, that means that our B value is going to be more than 100%. Means that B is going to be more than 1. Okay. So remember it's y is equal to a b raised to the x power. So this one is more than 1. The b value is more than 1. This one, b is actually more than 1. This one is less than 1. This one would be more than 1. This one is less. This one is, if we graphed it, you know, I want to graph them. So I'm going to put second division raised to the negative 0.5 x. Wonder everybody, I'm just going to make it a little bigger so we can see this. But anyways, let's see if we can see when we graph it. Okay. So everybody, it's definitely going down. So that means that it's decay. So it's not that one. So we have 3 that work. Okay, on this one it says Bonnie invested $12,000 in a fund that pays 3% compounded monthly. So it means N is going to be 12. The rate is going to be 0.03. Principal is 12,000. Okay. Clyde invested $3,000, so principal is 3,000. Paid 2%, so the rate is going to be 0.02. Remember, you can always divide by 100 to get the rate continuously. Okay, so that means we're going to be using E. What's Clyde's annual rate of return? Remember, that's going to be E raised to the rate. So I just do E raised to the 0.02. So we're going to do E raised to 0.02. I get 1.025, and I've rounded up. Okay, how much money does Bonnie have after 10 years? So that means our time. Okay, so we're going to be using our compound interest. A is equal to the principal. 1 minus the rate is a decimal divided by the number of times compounded, raised to the number of times compounded times the time. So I'm going to put in A is equal to 12,000, 1 plus 0.03 over 12, because it's compounded monthly, raised to 12 times 10. Okay, we're going to round to the cents place for that, so I put in 12,000, parentheses, 1 plus 0.03 divided by 12, raised to the 12 times 10. Okay, so we get 16,192 and 24 cents. Okay. Clyde eventually catches up with Bonnie. When and how many months? So you can graph this. So you can set them equal to each other, but I would actually definitely suggest graphing them to figure out when they are going to be the same. So for this one, for Clyde, it's going to be A is equal to 3,000 times E raised to the rate of 0.02x. Okay, so you put that in for that one. So we graph them. So 3,000 times second. This one actually I think would be easier to graph in decimals, just saying. And then we got 12,000. I'm changing the window to 100 so I can actually see it. That's already 12,000, so let's do 20,000. I'm going to go by thousands so we can actually see this. And even with them, I still can't see it. Okay, this one, everybody, honestly, graph it on decimals. It's just easier to see it. Okay, on that one, everybody, I know, I want to say this one I think was 84 months, but honestly, graph it on decimals. Okay, so this one, colony of bacteria started with 50 organisms. Everybody, so that's going to be our A value, and quadruples each day, so B is going to be 4. What's the range for the bacteria for 0 to 10 days? So 0 is going to be 10, 0, and then we put in 5, okay? So we put in times 4 raised to the 0 power, we get 50. And then 50 times 4 raised to the 5th power, we get 52,200. Okay, so that would be our range, everybody, our Y values. Okay, write a rule for G describing the stretch. Okay, so a vertical stretch by a factor of 4, followed by a translation 5 units down. Okay, so if we're doing a vertical stretch by 4, everybody remember Y is equal to A. B raised to the X minus H plus K. So vertical stretch by a factor of 4, that means our A value is going to be 4. So I'm going to take that function, multiply it by 4. Remember, this E has an invisible 1 in front of it. So we're going to get 4E X plus 3. 4 times 10 is going to give us minus 4. It says 5 units down, so minus 5. So it's going to be 4E X plus 3 minus 45. Okay, so this is our A value. Remember, H is X minus H, so H is opposite. So A is going to be 4, H is going to be negative 3. Remember, H is opposite. And K is going to be negative 45. Okay, that's it, everybody. Good luck.